the number 2 problem from the 1998 exam. I just want to kind of walk you through exactly how to do this problem and what is it that the College Board was looking for in order to get a complete answer on this of 4. The first question says, draw a histogram that shows the number of the frequencies of the number of defective items. So first thing we want to do is kind of set up our histogram. Now, I'm going to pay attention to this because they tell me which variable to pay attention to. If you're paying attention, you have 2 different variables on your axis. That's actually not okay. I need to be able to identify which variable is in play and which variable we need to kind of pay attention to. They mention the number of defective items, so that's what we're going to put down here. So we're going to put number of defective items. Okay, now on the x-axis, what I really need to be able to do is I'm going to write down the values that the defective items go to. So it starts off, of course, here at 0, and then it goes up to 1, 2, 3, 4, 5, and 6. Those are the values that it ranges, which actually only goes up to 5, but I'm going to go all the way down to 6. On the vertical axis, now this one is always going to be frequency, right? So how often did I have only 1 or 2 or 3 numbers of defective items? If you look at your histogram, or not histogram, but if you look at your dot plot, or sorry, your scatter plot in a horizontal fashion, then it'll tell you I got 2 different values that, I can kind of go down the list here and I can look at each one of these values and I can count up the number of dots. That'll tell you the frequency or the number of times that it occurred for that particular date. And so I'm going to go down here. For 1, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll go up to 9 because we only need to 8. So remember how you make a histogram. Bars must touch unless there's a reason for them to separate. I'm going to start and I'm going to make a bar for the number 1, and it's going to go from 1 to 2, but it won't include 2. I'm going to always put the number that the bar starts on inside that bar. So for 1, it's going to go up to 2. Right, so there's a frequency of 2 in that group. For 2, I'm going to count, that's 4. So I'm going to go all the way up to 4 here. Right, so there's 4 in that one. From 3 to 4, I have 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to go all the way up here to 8. All right, so there's 8 up there. I'm putting the number over each bar. That's something that's nice, not required, but you can if you want to. And then it seemingly gives me a perfectly symmetrical graph going back down to 4 and finally back down to 2. Right? So that's really nice. What was it that the College Board was looking for to grade this particular question? Number 1, they wanted the histogram to be done accurately. So there's that, right? Getting the bars right. They also wanted you to label the names, the variable in question here, and the axis. Same thing over here. They didn't require a title, but they did require the histogram to be labeled appropriately, both axes, and the correct histogram. Okay. Part B says, give one fact that's obvious from the histogram, but it's not obvious from the scatter plot. The one thing I think you can tell is that the histogram shows a very normally distributed things. Let's talk about what the College Board really wants out of some of these things. In this particular diagram, the College Board even accepts a bar chart type graph where you've written it down with spaces or not. Like I don't have spaces. If you have spaces here, they did not deduct for this. They accepted that. You could kind of count this in a categorical way if you sort of think about it. They also accepted frequency or relative frequency. If you did it as a percentage versus at counts, it really doesn't matter. Okay, part B here, they wanted you to say that it's symmetric and mound-shaped, or you had to use the phrase approximately normal. If you said normal distribution, you would not have gotten credit for this, because this is not perfect. I didn't check to see if it's perfectly normal or not. If it is, great, but apparently it's not, because they don't accept that answer. It would not be considered a complete response. Okay, you're welcome to give other descriptions like shape, center, and spread, but those things are not really required. Okay, what is required here is something about shape. That was the one thing that you had to mention. You could have said bell-shaped, mound-shaped, symmetric, approximately normal. Those are the different ones that were accepted. And the last one says, give one fact that is obvious from the histogram or from the scatter plot, but not from the histogram, right? So we're looking at scatter plot this time. The thing here is that there's a trend that over time, the number of defective items decreased. We can see that in a scatter plot, right? We can always talk about the trend, right? If you were to draw a line through this, you would see that this line would have a negative slope. That as time progressed, the number of defective items reduced. What did they really want from this? They wanted you to say that something about the trend across the time that it had less defective items. It said, let's see, the most obvious fact from the scatter plot is that the number of defects per day has a decreasing linear trend across the days. Let's see what was required. If you mentioned something as like negative correlation or negative association or negative slope, these are also correct possible answers. But if you talked about that there was a decreasing trend across time, you got full credit. It's not very specific. I'm looking at the response or the key right now. It says to get a 3, you would have to, well, this is an older test, and so they're not as clear about their responses. But point is, this was a really straightforward, really quick question that could have kind of shortcutted it and really not been clear about that and missed things like approximate or I don't know. Okay, so that's the end of 1998. Let's go on and look at number 2009, number 2. Number 2009, number 2, we are going to look at essentially normal distributions. This is like normal CDFs, inverse norm, with a few twists thrown in. This is a really great question. It really branches out over the course of the semesters and pulls together a lot of different topics. So let's kind of start on this. A tire manufacturer designs a new tread pattern for its all-weather tires. They tell us that they conducted it on cars of approximately the same weight, traveling at 60 miles per hour. The test showed that the new tread enables cars to stop completely in an average of 125 feet, right? So I'm going to write down the average. That's right. So mu equaled, well, let's go with x bar. I'm not sure if that's mu. My average is going to be equal to 125 feet. And they tell us the standard deviation is equal to 6.5. They also tell me that the stopping distances are normally distributed. So I'm going to draw my little curve here. Always a good idea, right? So 125 goes here. And they ask us, what is the 70th percentile? Well, I know that 50 is in the middle. If I went back to kind of this point, so 70 is probably somewhere like this, right? 70% goes here. Demonstrating that I understand what the mean is, the fact that it's normally distributed, and I've written down the standard deviation. These are all important parts to get full credit for this question. The really easy the easy way to do this is I need to know this number. What is the 70th percentile? Well, that's inverse norm, and I'm going to type in the percentile, the mean, and the standard deviation for this problem. This part right here is pretty important. If you didn't define this, now I might have been okay because I defined it over here and I showed this, but if I hadn't, I could have just done this part and then plugged it in. If I needed to include either this or this, right? I didn't need to do both, but I'm just showing you what you can do. Let's plug in the numbers. It's inverse, norm. This is going to be 0.7. The mean is 125, and standard deviation was 6.5. And this is going to get me about my number here. And that's how you get 128.4 feet in the problem. Now, I could have done this a couple of different ways. I think that's the easiest way without a doubt. There's other ways you could have created this, found the solution using a table or something like that. You could also use some other things, adding one standard deviation or adding a particular z-score. Yeah, but let's not do all that. Okay, the next question says, what is the probability that at least 2 out of 5? Okay, so I'm a little bit tricky, and I threw in this. And some of you that I talked to today realized this very quickly, which was really, really fantastic. That says it's binomial. When you have so many out of so many, things should be going off in your head. That sounds really familiar. How did we do that last time? This is how you're going to do it. I'm going to use binomial CDF, right? It's going to be N, and then P, and then X. And they tell us N here is 5. The probability is, we'll come back to that. And then X is exactly 2. And so if they tell me that the chance that is greater than the distance calculated, right? So I'm looking for what's the percent here, right? This is 0.3. This probability right in here, that's the chance that they're going to stop greater than the distance calculated in part A, right? Which is 128.4 feet. So that makes this really easy. So we can have 0.3 right there. Defining this and then showing you what those things are is relatively, well, it's important. I have to kind of talk about this. I needed to define the different things. I mentioned that it's binomial. I mentioned what N was, what P was, and what X was, rather than just throwing it into binomial CDF first. Now, it's greater than, right? This is at least 2. So if you remember, binomial CDF only does less than. So I'm going to have to do this. 1 minus the binomial CDF of, we're going to do 5 and 0.3, but I want to get rid of 0 and 1 and keep 2, 3, 4, and 5. So we're going to do 1 here, and that's going to kind of bring all of that stuff back together. Turns out that's going to give me 0.4718 as the probability to get it to stop. So 2 out of 5 cars should stop a greater distance than the result we got in part A, and that's going to give us the 47.18 or 0.4718 chances of that happening. In order to get full credit for this question, I needed to denote that it was binomial. I needed to define all the parameters that I was using. In other words, N, the sample size, the probability of success, and the number of trials that I was using. So denoting what was going into my binomial CDF was really important. I couldn't, if I had just put this part down right here, I would have only gotten partial credit. I needed to define it like this and tell you what the parameters were. Okay, next part. What is the probability that a randomly selected sample of 5 cars? Oh, okay, so we're changing something here. Okay, last time up in number 1, it was just a single car. Now we're going to do 5 cars, and we're going to do normal CDF, right? This is going to be lower, your upper and your mean, and then the standard deviation. That's going to be important here. I'm going to go ahead and draw a curve too. All right, my center's still going to be at 125 feet. Somewhere up here is 130. And what I'd like to know is it's up at least 130 feet, right? So that's all this. My standard deviation, now be careful, this is a sampling sampling distribution, because now not just 1 car, I have 5 cars. And so I'm going to have to make sure that I take that into consideration and calculate my new standard deviation, right? Last time it was 6.5 divided by the square root of 5. In fact, I'm required to do this calculation. 2.91 is my new standard deviation. So that's going to be, let's see, lower is going to be 130. The upper is going to be 1E99. The mean is still 125. And then we have 2.91. Now, if you put this formula in, let's say you took this and placed it here, that's also fine too. Just so long as you show them that you did recalculate standard deviation. Anyway, let me finish up my calculation. Turns out that if we do this, we're going to get 0.0427. Okay, just like in the other questions above, giving me this or this, not both, is required. If you only gave me this piece here, where you plugged it into normal CDF and gave me the answer, that's partial credit. If you did that for all three of them, there's a good chance that you could get just a 1 on this question, 1 or a 2, which is not indicative of what knowledge you brought to the table, right? It's just technicalities. I'm trying to give you guys a really good indication of what to do and get in the habit of this. If you haven't done it this way, you need to start doing that. Okay? Be careful and be specific. Okay? Any questions about this, please shoot me an email and we'll talk about it later.